Well, good afternoon. It's good to see so many of you here on a rainy spring day, because that's the spot of sunshine, I suppose, is that the fact it is a spring day. I'd like to welcome all of you today to the Clean Energy Speaker Series, a continuation of our discussion on the smart grid. I'd also like to welcome all of you participating on the webcast to today's presentation. So today's program, of course, is on data management, the smart grid and energy data measurement and management. And this is the second of a four-part series on the smart grid. Last month, we looked at the state of the grid. Next month, we'll look at the impact of plug-in hybrids and the grid. And then in May, we'll consider transmission issues of clean energy across the grid. So stay tuned for the upcoming programs. Copies of today's slides and, in fact, the archived slides of previous presentations, as well as the archived version of today's webcast and other webcasts, can be found on the website for the Clean Energy Speaker Series, secleanenergy.org. And I think you'll be treated to a new website when you go there, and appreciate your feedback and comments about our new look. Let me just take a moment to thank everyone for making this series possible. And oh, by the way, I'm Ben Hill. I'm with Georgia Tech and the ATDC, Georgia Tech's Technology Incubator Program. And it's a pleasure to serve as a host for today's event and facilitate this great discussion which we're going to have. I'd like to thank a number of groups and individuals who make this series possible. We have an extraordinary group of advisors whose bios are on the website. We have the support, the kind of visionary support, I would say, of firms like Sutherland, Asbill, and Brennan, McKinsey & Company, and Southface Institute. And then we also have the support of the Georgia Tech community. The Enterprise Innovation Institute, of which ATDC is a part, the Strategic Energy Institute, the Brooke Byers Institute for Sustainable Systems, and the Georgia Tech Office of Sustainability. We'd also like to thank GE for its support and participation in this great series. Thank you. So in terms of the program format for today, in a few minutes, I'll introduce our speakers. They'll make their presentations. Then it'll be followed by a Q&A session. And we'll conclude the program around 1:30. And for those of you participating here on site, when it comes time for the Q&As, we'll have microphones to pass around. Be sure to speak into the microphones so that it goes out over the webcast. And for those of you participating over the web, email your questions to me at ben.hill@georgiatech.edu. That's ben.hill@gatech.edu. And I'll be sure to pass those questions along to our speakers. This is a reminder, April 27th is our next program, same time, same location, when we will consider the impact of plug-in hybrid vehicles on the grid. So now I'd like to introduce our speakers, and we've got a great group of speakers today. To kick off this discussion, John McDonald, who's the Director of Technical Strategy and Policy Development for GE's Digital Energy Program, will begin the discussion. John has 35 years of experience in electricity, utility transmission, and distribution. He is the Director of Strategy and Policy Development, where he provides leadership and develops long-term plans to optimize GE Digital Energy's competitive position. This includes thought leadership activities, regulatory policy participation, education programs, and products and systems development. John is on the board of directors of the Smart Grid Consumer Collaborative. He's also the chair of the Smart Grid Interoperability Panel of the National Institutes of Standards and Technology, NIST, which is the touch point of the interoperability standards being developed in this country. He teaches a course on modern energy management here at Tech. He's published 35 papers and co-authored 3 books, and is a registered PE, professional engineer in California, Pennsylvania, and Georgia. He is a Boilermaker by education. He's got his BSEE and MSEE from Purdue, and he's a Golden Bear by business education. He has an MBA from UC Berkeley. Musaddiq Khan, MK, is the CEO and founder of Verdi Co. MK has over a dozen years of experience in marketing and developing software, and a bulk of that time has been spent in energy management and energy utilities industry, in advanced metering and smart grid technologies. He founded Verdi Co because he believes there's a better way to fulfill the promise of advanced meter reading and the smart grid through cost-effective solutions such as smart grid service and data streaming products, which we're going to learn more about. Before Verdi Co, MK was with Cellnet, which became Landis & Gear, and was involved as a product manager in various smart grid applications. MK holds a Bachelor of Administration degree in Computer Information Systems from Georgia State, so you're Panther. Right? And then we also have as our guest speaker Sanji Malik. Sanji is a founder and CEO of Urjanet, which provides business with a reliable source of data to help reduce energy costs and analyze and manage the economics of new and ongoing energy initiatives. Urjanet's U-Bus platform collects, transforms, and delivers an intelligent stream of energy, climate, and pricing data to business applications. Prior to Urjanet, Sanji has started 2 companies, so he's got serial entrepreneurship in his blood. He started Air2Web, which has today over 100 of the most trusted brands of the world engaged in using its services. And he also started Synchrologic, which created data synchronization tools for mobile devices, which was acquired by IntelliSync. Sanji holds a has a degree in mechanical engineering from the Indian Institute of Technology in Delhi, and master's degrees in engineering and computer science from the University of Florida. Go Gators. So I'd like to turn the program over to John, who's going to help set a framework for today's discussion. Thank you.
Thank you, Ben. It's a pleasure to be here, and especially to talk about a subject that I've have a lot of passion for. And you'll see as we go through some of these slides, the reason is that the tremendous amount of untapped benefits that are out there for electric utilities, and they could be realized through data management. Okay. And so I'll show you what the situation is that we have today with smart grid, and also what are the things that we've been working on for about 5 or 6 years, primary focus to try to realize these untapped benefits. One of the things with smart grid that you hear a lot is that we're adding more and more information to the system. Okay, but we have a lot of information already. And a lot of people say, well, there's a difference between data and information, right? Data is the raw data that comes from the devices, and information is what has value to us, right? So we convert the data into information, then it's usable, say, in applications, to drive applications. One of the things that in the late 80s, we came up with this term in the IEEE, Power and Energy Society, and it's the industry standard term worldwide now, Intelligent Electronic Device. We came up with the term IED before the Iraq War started. So when I talk about IED today, I really have to say this is the type of IED that we're talking about. It has two parts to it, to the definition. One would be internal computing capability, right? It's microprocessor based. But the second capability is what we need to take more advantage of, and that's the two-way communications capability of these devices. See, previously and in the field today, we have a lot of legacy devices that are electromechanical. You know, they're standalone and they have no communications, right? If you want to read values, you have to go to where the device is and read it. This opens up a tremendous opportunity for us because now each of these devices can be networked as part of a system, okay? And so in the late 80s, the marketplace, we just all of a sudden were flooded with new microprocessor-based devices, not with 10 or 15 data points in them, and not 100, but thousands of data points in each device, thousands. And initially, when we would talk to the customer, I've worked for 4 different automation system companies in the actually about 37 years now in the industry. And when you talk to the customer, they'd say, well, I've spent $5,000 for the device. I want every single data point extracted from the device and sent, upstream. I say, well, let's think about, how many of these data points really will you use in your system? A lot less than what the device has. So we really need to take a look at the data maps of the devices and say, let's not even extract the point and bring it upstream unless you know that there's a data owner for that, at least one in the organization, and how you'll use that data point. Okay, that's one of the challenges that we have. So over time now, the biggest change for these has been moving from proprietary communication protocols that we had previously to more industry standard protocols. So when we network these devices together, it's more easy, it's easier to do the integration because we have industry standard ways of talking. Ben mentioned, 2 years ago, the federal government ESA legislation passed in 2007, the Energy Independence and Security Act, and Title 13 of that set up a number of smart grid mechanisms and organizations in the federal government. What it did was it made NIST the overall coordinator for smart grid standards work in the United States. NIST is part of the Department of Commerce. We have 700 companies and 1,700 individuals now working on smart grid standards in the U.S. And we have a governing board of 25 people. And I was elected to the board 2 years ago, and the board elected me to chair the board, and I just got reelected. So we had a 4.5-hour board meeting yesterday morning in Nashville. And what we're doing is we have, there's 75 existing standards for smart grid that we need to take better advantage of. And every board meeting now, we have new standards that we're developing, that we're approving at the board level. We had 2 yesterday. Previous meeting, we had 3. Previous meeting, 2 of the 3 were involved with electric vehicles. And yesterday was smart meters and communications. Okay. Yes. The standards. We have a process that we have a catalog of standards, and before, from the board level, before it comes to the board, there's a very detailed process by which a long checklist of things that have to be, that standard has to go through a assessment process with respect to architecture, that it's not running over other things with respect to architecture and cybersecurity, privacy of information. It's a little bit of both, actually. It's the NIST folks, are paid by the government. The $10 million that the government gave to NIST to do this work helps staff an administrative company called Internex, and then the rest of us are volunteers. Okay. So, with respect to smart grid, probably one of the biggest sources of information is the substation, okay? And we're putting hundreds and hundreds of devices like this in substation. There's three primary levels of activity. This level, all utilities worldwide are active at this level, and this is putting new IEDs in substations, not old electromechanical devices, but new devices. Okay, so remember they have two-way communications capability. This level is the one that we haven't done a good job at to date, and that's taking advantage of the two-way communications and truly integrating these devices, okay, in a network. And then once you integrate them, there's things that we need to do, which I'll talk about in subsequent slides. Third level is once you have the data extracted and you're observing the behavior of the data, is an idea of what substation automation applications make sense to run at the substation level. And this is applications using the data to optimize the operation of that substation and the feeders, the distribution feeders, that come from the substation. Now, the reason this is so important is if we take a look at the United States, distribution is the part of the electric utility system that brings the power right to the customers, to our homes. There's 48,000 distribution substations in the United States. Only 15% of those have any kind of automation installed. Okay? So that's why with many utilities and many places in the United States, when your power goes out, the utility doesn't know that until you call them. Okay? So there's no automation in those substations. So problem occurs, there's no, and we can do it very inexpensively today with new technology. And to me, that's one of the focuses of smart grid, because we say we have large areas of unobservability in the system. We just don't know what's going on. So this is an area of great focus first, and then secondly would be the applications. Okay. What we mean by integration, I like to separate integration from automation because we need to integrate first. And with an industry standard that we passed about 5 or 6 years ago, which is the global standard on automating substations, we can integrate not only control and data acquisition, but also protection now. And we can do protection messaging in milliseconds on Ethernet LANs in the substation. Okay, and we only have less than a handful of those installations in the U.S. because of the risk averseness, let's say, of the electric utility industry. There's hundreds of installations outside North America. So one of the things that's happening in the next 5, 6 years is much more implementation of using this industry standard, which has tremendous benefits, very strong value proposition to the utilities, have to get through the over my dead body syndrome that we have with a lot of the senior engineers. So that's integration, and secondly is automation. Using the data in different ways to optimize the operation of the substation and the feeders. Now, this is the key concept. I wrote an article in 2003 introducing this concept to the industry, and now it's a standard. And I differentiated, when you look at a device, there's really two types of data. We really hadn't looked at it that way before. There's operational data and non-operational data. And up until 2003, as an industry, we only focused on what we call the operational data. And what we mean by that is the data in the devices that the operators in the control center need to monitor and control the power system. Right? So if you go to the Georgia Power building on the second floor, there's a huge room with video projection screens, and the entire state of Georgia is dispatched from that room. Okay? And so Ben talked about, Dr. Miliopoulos and I have taught a course, continuing education course here for 15 years on modern energy management systems. It's a 3-day course. The evening of the second day, we take the class to Georgia Power's control center, and we spend about 3 hours. And all the software applications we teach during the day, we see live demonstrations of those in the evening at the control center. Okay, so that's the data that's needed to operate the system. And the nice thing with that is it's fairly mature, so we're using industry standard communication protocols, and a widely used one in North America is Distributed Network Protocol 3. The real benefits here that are untapped are with what we call non-operational data. This is data that's in the device that the operators in the control center don't need, but other groups in the utility need. Okay, and examples of that would be the maintenance group. Okay, when we have a protective relay in a substation, it's connected to the circuit breaker, right? So when a fault occurs, the relays, right, sends a message to the circuit breaker to open up, right, to isolate the fault. Well, in that relay is maintenance information on the breaker. It has an indication of the energy of the arc that was interrupted, the I squared T, and also the operations count. How many times is the breaker operated? Well, that's valuable information for maintenance. But the protection group is siloed from the maintenance group. Protection group owns the device, see? So that information stays in the relay and typically is never extracted and sent to the maintenance group. In fact, the maintenance group may not even know that it exists. So I found that before I joined GE 3 years ago, I did 12 years of international consulting for electric utilities, and I worked with this constantly with utilities and cut down those silos and brought upwards of 20 to 25 groups together within the utility and just said, do you know that there's these devices in the field, and some of these devices have valuable data for you, for your group, and made that connection. Okay, so this is an area that even in the last 7-8 years, we really haven't done as much as we possibly can do. And then there's a remote access path. We always need the ability from outside the substation to access data in the substation. So we're showing a substation here. This is the control center. This is the operational side of the utility, so it's very much secure with firewalls. And then across the firewalls is a corporate network. And what we're saying is we put an enterprise data warehouse, some data repository on the corporate side. And then the 20, 25 or so groups, other than the operators in the control center, have desktop access on the corporate network to the data they need. Okay? So you see what the disconnect here is today. Tremendous amount of valuable data on the operational side, and a disconnect in the information infrastructure to get that data across the firewalls over to the IT side, corporate side, in a repository where a number of groups other than the operators have desktop access. So I say we've been focusing on the substation, the value proposition, and the substation only. And I've said that's half of the picture. We really need to focus on the enterprise value proposition. So we've talked just about substations, but then what we do is we look at all data sources throughout the utility and the enterprise. And this is where we get into enterprise data management. We look at the substations and feeders. We look at the power plants. We look at other systems in the utility. And we actually talk to all the operators and the 20 to 25 other groups and actually find out what are the data requirements point by point of each of those groups and build an enterprise data requirements matrix for the utility. I don't know how that came about, but this is a substation, the feeders, the control center, the enterprise. In red, we're showing the operational data. In green, the non-operational, and in blue is the remote access. So from outside the substation, I can pass through or loop through the equipment and isolate a particular device and check its parameters or even change its parameters remotely. So to sum up, the vision is a virtual data mart concept for enterprise data management. And the reason is that, you know, in any organization, there's a lot of data repositories that exist already. And you just, you know, one of the things with concepts like this is you realize in the real world, you just can't go in to an organization and say, well, we're going to replace everything that you have with this new concept, right? It just doesn't work that way. So they say, okay, here's our target concept. This is where we want to go. Now, what do you have in place? What's your legacy equipment? How much of that can be replaced, and how much of that do you want to continue to use? And then you figure out, okay, how can we, as close as possible, reach our target concept, but utilizing the legacy equipment that you want to stay, and maybe adding to it some new equipment. So it's a compromise with an existing situation. What we're talking about here is using the existing repositories and logically linking those together into a virtual data mart, right? With a federated data server that sits on top of all the existing repositories. So if you need 5 pieces of data, it may come from 3 physically separate repositories, but that's all transparent to you. You just want the data. You know, the data manager behind the scenes knows how to manage that data and knows where to get it. Okay, so we aren't changing what's existing, but we're enhancing it, adding to it. So we're bringing together all the different sources of data, right? And over on this side, we're showing all the different business owners in the electric utility that can provide more value to the organization if they have some of this additional data. Okay, and in the calculations I've done in 12 years of consulting, basically what I've shown is that today the utilities investments in devices, at best, they're realizing about 20% of the potential benefits of the investment in their devices, their IEDs. There's 80% of untapped benefits. And there's, I got 7, 8 different steps, basically, that to follow to get to that 100% point. It's not difficult to do. The challenge, and I'm interested to hear what the 2 other speakers have to say on this topic, but the challenge for us is smart grid is very much of a holistic concept. The utility, the only way utility is going to be successful with smart grid is you got to break down the silos of the different groups, and everyone's got to work together. And the utilities that have been successful in that, we've been working with AEP, American Electric Power in Columbus, Ohio. Mike Morris, the CEO, basically mandated to the utility, you will work together. We will be successful in smart grid. All of you will work together to develop a roadmap and strategy for the whole utility. And we're not going to have, siloed projects. We're going to work as one. Only when that happens do we really have a chance, does the utility have a chance to be successful? Because breaking down those silos and truly being holistic doesn't happen naturally. It needs a driver, a strong driver. Same thing has to happen to companies like us, GE. We have lots of different businesses that have different parts of smart grid. The business I'm in has most of smart grid, digital energy, but we work with our smart appliance group, right, to bring together home energy management solutions. These appliances today are like Star Trek, with the technology that's embedded, the two-way communications, and the capabilities, but those need to talk to the systems that we're doing, right? So we need a holistic approach within GE for all of our businesses to work together and be incentivized to produce another tier of benefits, not only the benefits from our individual P&L, our business, but an additional tier of benefits, which is, what additional benefits can we provide by bringing the businesses together? Okay, and that's really what smart grid is. So to me, one of the biggest challenges is this enterprise data management, and it's the key, one of the biggest keys, I think, to success. I think that's my last slide. Yeah. Okay. So I appreciate it.
Thank you, John. Ben, thanks for the opportunity to the ATDC. I'm MK, founder and CEO of Verdi Co, and what we do is we offer basically a platform to exactly do what John was kind of talking about, is to really dig into the untapped data that's really available today to the utilities out there. What I'll start with by saying is that I was at a conference a few weeks ago for the cooperatives, Take Advantage, which is really Verdi Co's target market. And a gentleman by the name of Burley Davis Jr. From Palmetto Cooperative used the term smart grid, and I've kind of borrowed that term from him. And the reason is, in last week's series, uh, uh, Dr. Dewan talked about the reliability of this of the grid that we have today. And in the past few days, with all the storms and everything, I really didn't see a power outage in my house. So for the most part, I always thought that the grid that we have was pretty smart already. We're just trying to make it smarter. And the next paradigm shift that's happening in the grid and in the utility industry is really more towards efficiency. So having said that, I'll start with what the smarter grid is not. And what you see out there, out here is a smart meter, and most people equate or used to equate a smart grid with a smart meter. And although it is one of the basic tenets or one of the primary tenets that we're starting off with, but really that is maybe 10 or 20% of what the smart grid is. There's a lot of different pieces of the puzzles out there that will make this grid smarter as we have it today. The other thing is the data that we all talk about, this big data issue, is not only relevant to the utility industry. It's been out there for a while. If you look at some of the companies that are really looking at big data, like Google and Facebook, if you look at Facebook has 300 million users, 15 million concurrent users. When we're updating our kids' pictures or updating our status, we do it in milliseconds, and we don't think about it. But these companies have been tackling big data for a while. It's just a little bit new to the utility industry, who has not been looking at it and really has been, like looking at monthly reads from meters or not, leaving the 80% untapped data out there. So, and then what John talked about a little while ago is that data is not information. The data that comes in, it's raw, it's unvalidated, and really it needs to be sort of analyzed and really, kind of, the information really needs to be extracted from that. So let's talk about the smarter grid evolution, and I'll start with the meter since everybody's very familiar with smart meter and everybody talks about it. We started with manual reads, which is the utility guy used to come to our, in our back door, in our backyards, read the meter. Sometimes, I don't know, if they saw a dog, they wouldn't. So it would be estimated, right? And so we really got used to some of the low bills, and that's why you hear some of the complaints. I think in the Pacific Gas Electric, these press releases where they're complaining about high reads, and maybe they're more accurate reads that they never got before. Then we went into the drive-by or the automated meter reading, or AMR, what they call, which is the monthly reads. Instead of the utility guy having to walk out to your meter, they would just drive by and just get the read, into their cars, through these radios. And then we went to a little bit more of an advanced technology of AMR, which is a radio frequency read, and that is Cellnet, the company I used to work for, came up with it in the early 90s, where they would do a one-way read directly onto the utility's back office or Cellnet's NOC, and they would basically take that read and give it back to the utilities and charge them for that. And that was a little bit more of an advanced AMR. And then some of the cooperatives, about 65% of cooperatives that we talk to today have actually an AMR system that gets them an hourly read. So these are not the new smart meters that everybody talks about, but these are some of the older meters, but they get them hourly reads every hour. But the issue is the same. The issue is the same about, it's still untapped data, because the business case behind getting those hourly reads was to really get the meter readers off the ground or off the field, or the trucks off the field. And that was a real business case. There was no business case really thought through about the data itself, that what are they going to do with it. They brought the data in, they archived it, and a lot of times they pursed it. And now we're coming into the AMI world, the 15-minute intervals, where we're talking about every 15 minutes. Some utilities are talking about every 5 minutes, and there's some utilities talking about every minute. So, looking at the, I'm gonna get some of the TLAs, the three-letter acronyms out of the way. So AMI, Advanced Metering Infrastructure, or Automated Meter Reading, AMR, GIS, Geographic Information Systems, um, outage management systems, OMS, BPL, broadband or power line, radio frequency network, RF networks, SCADA, which is very common, supervisory control, and acquisition of distribution automation, data assets, digital substations. So these are all the systems that the utility already had, but now these systems are sort of getting stressed and inundated with more data that the utility is getting, whether it be from smart meters, whether it be from smarter substations, where they're digitizing all these substations with sensors, as John mentioned, with IEDs, and some of them are being upgraded. And then on top of that, utilities are also looking at kind of, some of the cooperatives are looking at, additional data from the consumer side, because as some of the cooperatives, as you may or may not, a lot of the cooperative utilities are member owned, so they're all trying to look at add, always trying to add value to their members. So what is a smarter grid? And this is what it is. It's really about IT. In the last segment, John talked about OT, or operational transaction, or operational data, and now that data is being over kind of cross section with, into the IT world, where the IT departments of the utilities are really starting to take a look at this data and really start, starting to get involved with, with everything that's going on with it. Um, so there's more frequent data. So you had once a month data to every 15-minute interval. So from 12 times a year, you're looking at about 35,000, thousand times a year, and that's per meter. And so if you look at the data growth, here's an example. If you look at 100,000 meters with interval data, let's say every 15 minutes, you're looking at online display, or online storage of about 250 gigabytes. You add the different parts of the register reads and summary reads and staging, and that's another additional 50 gigabytes, about 300 gigabytes per year for about 100,000 meter utility, which is an average a little bit on the higher side of a cooperative or a municipality. But if you look at some of the IOUs, or the investor-owned utilities, or the bigger utilities such as Southern Company, who have more than a million, up to 4 or 5 million, you're looking at terabytes and terabytes of data growth year after year. So, and then there's new sources of data. You not only have smart meters, you have electric vehicles, you have the emergence of photovoltaics, or solar and renewables, and then storage energy and the microgrids out there. And those are key parts of really delivering the smarter grid, because in the last series, I think Humayun and Tai of McKinsey talked about where the real benefit, or the ROI for the consumers from the smarter grid, comes in integrating these different technologies. So now there's new types of data. You have operational data, of course, which is the sort of the events in the field, and then you have the device and sensor data. You have application data from different new applications that are being put out there. You have the network event data of all the different networks. A lot of the utilities, when they put out a smart meter, they're not looking at a single type of network. They're looking at a combination of network. So if you look at the 5 stages of a smart grid data sort of cycle, it starts with a generation. And when I say generation, I'm not talking about the power generation, but I'm talking about the data generation at the consumer level, or at the meter level. Data comes in, it goes in through through the transport layer, and then it sort of comes into the utilities back end, where there is some sort of integration pipeline that it kind of disperses into the different silos in the utility back office. Once it goes there, then the real transformation begins to happen, and that's where the data is really starts to get tapped for value. And then the last step is sort of integration, which is a really big big issue out there, specifically for the mid-sized utilities, because some of the bigger utilities have a lot of budget. And again, I'll go back to last series where Humayun and I talked about bad money after bad money thrown at integration, because it's a real problem. I know an Encore spent, the utility in Texas spent about um, 40 million meters, $40 million to integrate all the different systems as they were putting in their smart meter program. So this causes the utilities back office to come under a lot of stress, and basically, with the you have new device data, you have new systems, you have additional silos. So every time, it seems like the smart grid is sort of kind of becoming a headache in many ways, because as the utility puts on these smart meters, now they're thinking about, how do I manage the smart meter, this new data? So they put in an MDM. Then they say, okay, well, an MDM is not enough. I need to analyze this data. Then they add an analytics warehouse. Then they're like, oh, well, wait a minute. This analytics warehouse is great, but I need some more advanced analytics. So then they go on and buy an advanced analytics engine, and slowly these silos keep on growing, and there's no end to it. So what are some of the challenges facing data utilities, data challenges facing the utilities are being faced with? The first thing is correlating this information. And we as we use the internet today, we don't think about it. We use Facebook, and we know exactly who my friend is connected to, or who should I be connecting with, or I look at LinkedIn and I can say who looked at my profile last time. These are all data correlations, and it doesn't happen as almost at all in the utilities, or to the extent that they would like it to. The other thing is scale. In terms of scale, like how these terabytes of data that comes in, they're going into these back office system that was placed about 20, 30 years ago. Okay, and then these vendors come in, and then they say, okay, let's add more licenses. I don't want to pick out names, but some of the some of the real big vendors out there, it's about $50,000 per CPU license. A decent sized utility needs about 4 CPUs. That's about $200,000 right out the door. And then adapting the new processes, transforming the business process to really manage this new business of smart grid. And the most daunting task for the utility is to manage these silos as they grow. So each time they put in a new system, they talk about integrating that system. They talk about and one of the biggest issues facing is in this industry is standards. Now, the thing that has happened over the last 2 years is that with the smart grid initiative, that process has been sort of expedited, and that's great, but still not there. So some of the, if you look at the mid-market utilities, like the cooperatives, they actually went and made their own standard. They said, we don't have all the money to spend in all this integration efforts. So what we're going to do is we're going to make every vendor follow a standard, and that is multi-speak. And for a vendor to do business with us, you need to implement multi-speak standard or conform to the multi-speak standard. So some of the smaller utilities have kind of addressed that, but still there's work to be done there. And then the cost. I mean, think about it. I know we say hardware is cheap and this and that, but how much can you as you increase your data infrastructure or back office infrastructure, how much more can you keep on adding? You're talking about being green, you're talking about being efficient, and then you keep on adding. What is that? Is this kind of like a, I mean, there's some, it just doesn't add up. The other big challenge that is not here at all is security, and that I think it'll take a whole nother. I think there's probably another series plan just on security, because that's a whole issue in and of itself. But this also means new possibilities, new ways of managing load, new ways of shaping load, new ways of flattening load. And that's a big issue, because the utilities, for the longest time, they know where the peaks are. I mean, like I said, for the most part, they are pretty smart. They know where the peaks are, but they don't know where, what they can do about that. How can they flatten that, load out? things like, if they reduce, let's say, the conservative, the conservation voltage rate, uh, reduction rate, bring that down. It can save an average utility about, $2 or $3 million just by reducing the voltage that goes out in the customer premises. Revenue protection, looking at theft, looking at tamper. There, one of the founders of the company used to work and founded actually, a company called Ecologic, and over there, and he was working for another smart meter company, Trilliant. And over there, he actually, they actually were they had a lot of problems with theft. In one instance, there was this guy, I mean, he had, like ridiculously low reads, and they kind of looked, they looked at it over year, and finally they realized that, he was growing, pot in his garage. So, I mean, and so what he did was he drilled a very fine needle into his meter and kind of slowed down the rotation. So, so really, that's ingenuity, but I mean, on the other side. Now, and then demand response is one of the things that has been talked about a lot. Although again, from last series, who might think that that's a waste, but customer engagement is a big part of the smarter grid. And then accurate billing. There's still issues with billing, and a great example is the Pacific Gas Electric story, where customers are saying, no, I don't want a smart meter because it increases my reads or it increases my bill, right? Okay, fine. That means that they're going to put in back the old meters. That gives them even more of a reason to make sure that they get the right data now, because before they weren't. And maybe they'll see that after the old meters, still their reads are the same, because now the utilities are managing data better, or estimating the reads better. And then advanced outage, what John just talked about, like utilities really don't know until you call the first time or the second time and the third time that, okay, this area has an outage, and it's not just that particular household. So what kind of efficiencies are we looking at? I mean, what are the utilities looking for? So if doing theft management or tamper, or being able to detect tamper, or being able to forecast a better peak, or being able to accurately forecast weather and correlate that across your data, can give you 2 to 4% for 4% of annual revenues. The other thing is truck rollouts. There's an outage, there's a problem, the customer calls, and a truck gets rolled out. Per truck rollout, it costs a utility about $150, and there's about 100 average in some utilities, about 100,000 truck rollouts a year. That's $15 million of truck rollouts a year, and 30% of that is sometimes false positives. The truck goes out, they go to the customer, and everything is fine, and it's actually the customer's circuit board. The customer calls, says there's an outage. The utilities go out there, they go on the wrong line and go address a wrong substation. False positive. There's about 30% of that. So imagine, just saving on that. Then looking at overloaded or even underused transformers. I mean, there's been instances where utilities have sort of added households to a single transformer, and one transformer out there is completely left unused. So underused transformers, and then the ones that are being overused all the time, they're having to replace. So that's about average 60,000 for a smaller utility, can go up to 120 plus for some of the bigger utilities out there. Voltage optimization. That's one of the biggest things that's out there, is that reducing the voltage can greatly not only reduce line losses, can reduce stress on your substations, and at the end of the day, reduce bills for your customer. Yes, so you get to bill the customer less, but you also get to save a lot more money on the other end. So it's kind of a win-win situation there. And then customer service. We were at a utility, and the guy, a customer called. He spent almost 15 minutes with a customer, and he had like 6 or 7 windows open. The customer said, they had a $300 bill one day, so he had to open up the billing system. Then he said, okay, let me go into my smart meter system or AMI system or the one that they have already to see, okay, is the meter working? Then they have to say, okay, let me look at the weather. They go to the weather channel and look at the weather. Then they go say, okay, well, let me see if there was an outage. They go to the outage management system. And it goes back and forth. So imagine if they can bring that 15-minute down to a single, to 5 minutes by looking at the data in an aggregated fashion, then that's a huge saving. He can address more customers and so on and so forth. So data is just not, it's not going to, and as I was saying, it's not going to give you information. You have to you have to you have to extract the information. And as John was saying, untapped data. The utility has data today. That 80% of it is not being used. 80% of it is stored somewhere. So some of the short-term objectives by looking at this data is like, through advanced analytics, kind of really going and extracting and aggregating some of the existing data. Not integration. Integration is, a whole different ballgame. It's a much more complex issue where you want to see something, when something happens in point A, that result is in point B. It's aggregation, getting the data into a single place, and then really, kind of extracting the information by analyzing it. Identifying cost savings, and then, of course, looking at ROI based on existing data to justify your ROI for the future smart implementation of a smart grid. There's by this time we all know there's no more money from the government, so that's done. I mean, whatever who's ever got it, got it. The utilities, but the smart grid is real. They're going to do it. It's nationwide. It's mandated. It's it's talked about. Everybody's going to do it. But what's not going to happen is they're not going to do it, like Southern Cal Edison did, across their network. They're going to pick and choose what parts make sense, and they're going to apply it to those parts first, and then gradually they're going to ramp up. Nobody's going to spend billions and billions in with a single vendor, or with a single in a single initiative. So these are some of the things that are problematic with some of the existing data solutions out there. One of the things is that cost. Okay, the traditional databases of the old days is first of all hard to manage, costly to buy, and then limited scalability. Closed and proprietary systems is another problem. And a lot of these utilities have kind of built homegrown systems, and limited scalability. So, they're siloed. Data is still siloed. It doesn't scale. The scope is limited, and then cost is is very high cost. So, what are the solutions driving? So, traditionally from online transaction processing to proprietary warehouse. Now, they're looking at a whole brand of new architectures and new types of databases. The utilities are gradually moving from their in-house NOCs and slowly but surely moving to the cloud. And some of these are public clouds, some of these are private clouds. But some of from the mid-market utilities, that makes a lot of sense because they don't have to invest more in their existing infrastructure. And so that's we're going from requirements driven to results driven database systems or data management systems. From enterprise silos, we're going into hybrid clouds, and then we're really driving down cost. And at the end of the day, it's about getting the utility up and running as quickly as possible without charging them and really doing custom development. So with that said, I turn it over to Sanjay. Thank you very much.
Thank you. My name is Sanjay Malik, and I'm the CEO of Urjanet. And we deal with the data problem, but we have a different perspective on the data problem. I know John and MK talked about data as it's affecting all the different utilities. We deal with data that is affecting businesses. So our customers are businesses that spend a lot of money on energy, who are focused on looking at carbon and energy spend and all the prices going up all the time and managing that. So our philosophy is that we are concerned about double green. That means we have to be green in terms of carbon, but we also have to save money on energy, which is very important to the businesses as they go forward. All right, thank you. So I sort of take John's example of Afghanistan quite literally. He was producing IEDs, and they are producing an explosion of data. So there is some. That is not a bad analogy. But as John and MK pointed out, there's a lot of data. There is exponentially larger amounts of data today than there was even a few years ago. So that problem is definitely affecting the utilities, which is what MK talked about. But it is also creating lots of challenges and opportunities for businesses. And that's really what I am going to spend a little time on today. The smart grid has produced a data-driven ecosystem, and that has created lots of opportunities for businesses. But what are some of the problems that businesses are trying to solve? One of the problem is that they want to reduce energy costs. It's a big part. It shows up on your balance sheet. It's pretty significant. So anything they can do to not only reduce costs, but also manage the risk of energy prices fluctuating all the time, be able to do better budgeting is important to them. They are also becoming more concerned about carbon management, carbon footprint. If you look at most Fortune 500 corporation, they have goals in terms of how much they should be reducing their carbon footprint over a period of time. So to manage and measure that is important to them. And lastly, they are also looking at alternate energy systems, which means that they're looking at fuel cells, they're looking at wind turbines, they're looking at solar panels, but very few of them actually understand what the impact of that is going to be. So if a plant engineering manager comes in to the CFO and says that, okay, it's a great idea to install solar panels on the roof of our factory, the CFO is going to ask them, like, what's the impact? What is the ROI on it? And sometimes those questions are complicated and the answers are difficult to get. So again, data is central to making sure that all these questions get answered. So what is energy data? What do we mean by energy data, or what is the context for businesses for energy data? It is electricity and natural gas billing, pricing. So you have demand, consumption, uh, billing data, historical use of electricity and natural gas. You have the different tariffs and rate plans, whether they are time of use rate plans, whether they are contracted rate plans, whether there is some kind of a demand response rate plan that the business might be using. There is weather information because of the fact that a facility located in Massachusetts is going to behave very differently from a facility located in Florida. You have to have weather normalization. You have to have figure out heating and cooling days. So weather plays a part in terms of understanding your energy use. Uh, MK talked about interval metering. That is producing a lot of different kinds of data, which is necessary not only for understanding what your consumption and demand is, but also behavior modification. What happens during the day? What happens when you turn on the HVAC system? Uh, so the behavior response and load shaping becomes very, very important. And then there is other types of data which may relate to other resources which are linked to energy, like water and other resources like steam. And then there is, of course, alternate energy systems and data about carbon. So there is a lot of different kinds of data that a business needs to actually understand its energy use and manage its carbon. So what I'm going to do is talk a little bit about what we are doing to provide businesses with data that they need. Urjanet provides a platform and a data service. We have a cloud-based platform that gathers this data and information from many different sources. It's utilities, it is weather stations, it is building management systems, it is smart meters. So there's a lot of information and data that is coming along. What we do is provide a data service which is based on a cloud-based platform, but it is a subscription-based service. So there is nothing that a business needs to actually install. There's no licenses to buy, there's no software to install. It is more like you would use Bloomberg to pipe it into your financial systems. So this is our service, and this service, data service, actually connects with systems and applications that the business might already have. So you may have a SAP system that you use for accounts payable. So the billing data actually feeds into the SAP system. There might be an energy dashboard that you are using to manage energy use or monitor what your consumption is. So this data feed will directly feed into that. So what that has done is that kind of separated the data subscription from all the applications that are being used. And so we have a sort of pretty wide swath of applications that we can support. So who needs this data? What are the kinds of businesses that are looking at this data? So there are about 17 million commercial and industrial electricity and natural gas users in the US. So our target market is electricity and natural gas users that are spending lots of money on electricity and natural gas. So they are concerned about saving money and spending less and managing the carbon associated with that energy spend. Another sort of good statistic is that there are 262,000 users in the US that use some kind of demand side management. That means that they have a large enough energy spend to be concerned about using techniques like demand side management. So those are sort of good targets for us as well. There's a lot of investment going into the smart grid. What that is really doing is producing more and more data. So that, of course, becomes an opportunity for the businesses to use some of that data to manage their energy spend and manage their carbon. So who within a business might be using this? You have usually large corporate procurement departments. These are the folks that are managing millions of dollars, hundreds of millions of dollars of energy spend. As an example, one of our customers is Cox Enterprises. They spend about $100 million on energy every year. Another customer is UPS. They spend $300 million on electricity and natural gas. Of course, UPS spends $2 billion on energy because they have all these planes flying around and trucks going around, but on electricity and natural gas, it's still a very substantial spend. IBM spends about $600 million on electricity and natural gas. So there are large corporations where energy spend is a very significant item. And essentially, as corporate procurement is looking at budget planning or managing energy risk or getting the right rate plans from the utilities, getting accurate data becomes very important. Similarly, for facilities management folks, these are folks that are putting LED lighting and improving the efficiency of buildings, etc. This is an important source of information. When you're paying bills in finance and accounts payable, this is very important. So there is a whole swath of different users within each business that are needing energy data. And they're using it for different things, but it is very, very critical operations for the business as a whole. So when we focused on getting UrjaNet off the ground, the goal was to focus on data. And what we found was that because the ecosystem within the utility industries and the whole electricity, power, and natural gas ecosystem was changing, this was the first time that data became very important to managing processes that I've described before. So what we decided to do was only focus on data. So what we don't do is we don't come and tell you how to improve your efficiency. We don't come and tell you how to make your building more efficient. We don't come and tell you to how to procure energy or how to put a collar around energy risk for natural gas. We don't do a lot of different things. All we do is provide data that helps you do that. Essentially, there has been a huge technology shift related to how we are providing the data. We are actually working with Georgia Tech to put some innovation in place in the collection processes, which have been completely automated. So by the end of this year, we will be connecting to thousands of different utilities and automatically collecting data on our customers' behalf. There's been a substantial amount of innovation in the data model itself because the energy data, there was no standards for how energy data is provided. So we have created those standards. And lastly, we are providing it in a way that is easy for the customers and applications to consume. So it's a subscription-based service which connects directly into your applications. And then, of course, if we are a provider of data, we live and die by the accuracy and completeness and semantic correctness of the data. So that becomes very, very important. So one of the things I wanted to do was just sort of explain how a corporation uses data through the eyes of one of our customers. Robert Ferry, who's been quoted here, is actually sitting in the audience in the back. Robert, if you can make yourself known. Yeah. So as I mentioned, Cox spends about $100 million on energy spend, natural gas, and electricity. So this is an important part of a line item on their balance sheet. And what we are doing is we are getting data from about 30,000 different locations within the US and Canada, which are Cox locations. And you can imagine all these locations are connected to different utilities. Some of them are smaller utilities like munis and EMCs. Some of them are very large utilities. The data comes in different forms and shapes. So it is a very challenging task that our platform is performing in terms of actually automatically connecting and getting this information for Cox. And Cox is using this data in their procurement department. to manage and look at different aspects of cost and rate plans and manage energy risk. But they're also looking at it in their billing department. That means they need to, instead of getting boxes and boxes of bills every month and having to go through all those things and figure out whether it makes sense or whether I'm going to be disconnected, that I have late fees or not late fees. All they do now is get a stream of information that helps them look at their debits and bill payment stuff. So it has, again, automated a very, very complicated and tedious process that they were looking at. And of course, they have been able to make significant improvements in terms of their cost, but they also have a very active carbon management program, which is looking at reducing their carbon footprint by 20% in the next few years. So managing that and measuring that is enabled by the data that we provide today. So how does Cox actually do this? They have an energy dashboard that lets them do this sort of on an ongoing basis. And what we've seen is that all our customers and all the big businesses have energy management systems that are fairly sophisticated. They may be systems that have been developed in-house, or they may be systems that have been developed by a third party or standard applications. But what was missing was there was no clean data to drive these systems. So the Cox Energy Dashboard has been developed by Cox in-house. And so some of the kind of things that do is look at like historical information. So comparing what has happened at this site with what happened last year and the year before, right? So looking at that for not only the energy cost, but also usage and demand side. So they're able to compare how I am doing related to how I was doing. Am I improving as compared to what I was doing before? And another thing they might be doing is looking at usage, but looking at usage of a site, the same site, over a couple of years, right? So for one particular site, instead of comparing locations, but now I'm comparing the same site and going back in history, and so seeing patterns of usage and consumption. So that again becomes very important, especially if you made some improvements in the facilities. You installed LED lighting to see kind of, okay, yes, I spent a couple of $100,000 on installing these improvements. What happened? Did I make a difference in terms of what I was doing before? And lastly, like many other large businesses, Cox is also concerned and aggressively pursuing carbon management goals, carbon footprint goals. And one of the things that we do is we provide energy data that helps them make analytical judgments and measure and manage their scope 1 and scope 2 carbon footprint. So whether it's all the direct stuff or whether it's indirect stuff related to getting electricity from the utilities, what they're able to do is finally have a way of accurately measuring that. Because energy constitutes about 75% typically of your carbon footprint, it becomes a very significant portion of how you manage and measure your carbon footprint. So finally, what I'd like to say is that data is essential. Data is how we manage our lives, whether that's on the internet, as MK pointed out, with Google and so forth, or it is in many other areas, whether it's in financial services, where you're looking at automatically at bank statements and managing your portfolios. Utilities in the energy space is probably the last area to be automated. And we are glad that it is being automated, but it has created a lot of challenges. And we are looking at these challenges from the perspective of businesses that are consuming and using energy. So that's my last slide. And we do have a case study, which is, I think, very informative in terms of how a business actually used data to reduce cost and manage their carbon footprint, which is available on our website. Somebody needs to find it. All right. Thank you very much.
Thank you very much. Could our speakers mind sitting at the front, and we'll touch on the question and answer session. So there's some questions in the audience.
Greg O'Brien, question for Sanjay regarding standardization. The ASTM BEPA standard just came out, Building Energy Performance Assessment. Is that something that UrgeNet is tied into? And the idea is it's going to be like a phase 1 environmental. Before a building can sell, it has to have a standardized report with regards to energy management.
So we are connecting to a lot of energy and building management systems, and we are looking at many different kinds of standards. But essentially, one of the things that to remember is that we are outside the building. There are many different systems that are available from Schneider and GE and many other people that manage energy consumption inside the building, and they look at different systems. So we collect data from that system and incorporate it into our data feed. But I know there are some folks from UrgeNet here, but if you want, we can discuss particulars after this meeting.
Anyone else? Just remind everyone to speak into the microphone since it's being webcast.
Dennis Creech with the South Face Energy Institute. Each of you talked about the potential for energy efficiency from a smarter grid. Have you seen many utilities able to capture that now and looking at it as offsetting the need for new supply options yet, or are we still in the future for that? At utility scale.
Right. You know, where we have started is on the upstream of the customer. Particularly with respect to residential customers, that's the potential's there, but we really haven't have a lot of experience with that, except for some pilot projects. But think about on the grid side, a lot of investment hasn't been made yet in the distribution system. It has in transmission and generation, and we have, of all the smart grid solutions that we can do, the strongest value proposition is efficiency on the distribution system, improving it. And just John Wellinghoff, who's the chairman of FERC, said last year, if we can improve the efficiency of distribution in the United States by 2%, it would save building 42 large coal-fired power plants. So it's significant. The technology is there. We have it. MK talked about we can lower voltage, which lowers demand. Problem is we can do it during peak periods, but policy doesn't yet support utilities doing it off-peak. Okay? The average voltage today at a home is 122.5. The national standard is 114 to 126. The reason it's so high is the higher the voltage, the higher your electricity bill is. Okay? So if we lower the voltage to 118, you wouldn't see that at home. That 4.5 volt difference frees up a tremendous amount of infrastructure in the distribution system. But utilities aren't incentivized to conserve, right? The utility is incentivized to make money, and they make money by selling more electricity. There's about half a dozen states in the U.S. that have decoupled rates, where the state public utility commissions have said, we want you to conserve, and the money you give up by conserving, we will compensate you in other ways to make you whole. California was the leader in that. So I see tremendous potential for energy efficiency, but two things need to come along with the technology: policy to support it, and second is standards. And the customer side, on the residential side, demand optimization and smart metering, we're just getting into that. Pilot projects have shown an average of 10 to 15% savings, with a typical residential customer. But the biggest difference today and I agree with MK, it's a smarter grid, because we've been adding intelligence to the grid for many years, but incrementally we're doing some additional things now. Is that what we've done previously with residential customers is direct load control, where you would save money on the 4 peak periods in the summer, but I would send a signal directly to your air conditioner, compressor, your electric water heater, or your pool pump. Now we're adding the intelligence and the tools in the home, where as a consumer you manage your own electricity use. The price of electricity is coming to your home from the utility, where the peak price may be 50 times higher than the off-peak price, but you manage your use through the tools that we provide you. So it's empowering the customer to manage their energy use without compromising your lifestyle. And that, we're at the tip of the iceberg with that. I really think there's tremendous savings there, but again, we need policy to support dynamic pricing, time of use rates, and there aren't a lot of states yet in the United States that support that. So I say it's a three-legged stool, and they all have to work together. And that's why my role at GE is those 3 legs: strategy, standards, and policy. We could have 2 of those very, very strong, but the other one could prevent the other 2 from ever being successful.
Other questions? We have a question from one of our webcast participants. Would the panel speak to data ownership and data confidentiality?
So I just wanted to add to John's comments from the previous question about offsetting supply. One of the things we have seen is that the cooperative market is a little bit ahead, and specifically some of the forward-looking cooperatives. And an example is in the North Carolina area, where the G&T, or the generation and transmission cooperatives, are really looking at ways where they can apply better forecasting in terms of how much power they buy, so that they can in turn bring that savings down to the distribution co-ops. And as you know, the distribution co-ops are owned by the members, and so at the end of the day, if you are in a distribution co-op co-op territory, I don't know, every few years you get a check back because they're able to drive profitability. Going to the question of data ownership, it's sort of a very thin line at the moment, and vendors try to, we have seen vendors try to get what they can, and then if the cooperatives or the utilities are smarter, they try to push back. But at some point, there is value, and I think in last series somebody said that, somebody's going to figure out how to derive that value from the data, and really, at the end of the day, I think there should be a handshake between the data. It shouldn't just be owned by a single entity, because at the end of the day, it's really the consumer's data. It's your data.
So I would agree with MK. This was a big concern as we were sort of starting working with the utilities, but we have been able to clearly establish that the data belongs to the customers, and if it relates to their consumption, usage, billing, any other aspects of how they are using utility services, the data belongs to the customers, and the utilities agree that that is the case.
Let me say that we've adopted a model, and it's the only one that I'm aware of in the world. It's called Privacy by Design, and it was developed by Province of Ontario in Canada. Has an Information and Privacy Commissioner, Ann Kavukian, Dr. Ann Kavukian, who's developed a model of privacy of information that has 7 basic tenets. And we've taken that, operationalized it in the hardware and software that we provide for Smart Grid. And the first implementation of that has been at Hydro One, which is a project in Toronto, together with IBM and Telvent. So 3 of us have worked together on this advanced distribution automation project. It's really the first time where anyone's taken the privacy model, and implemented it. And it can't be bolted on, to technology that exists. You really need to, from the very beginning, need to incorporate that in the development.
Other questions?
Thanks to all the panelists for being engaged in an enterprise that has a lot of public good attached to it. I'm just wondering if we need some finer technology than smart grid. I think when Congress, for instance, passed the $7,000 tax credit for the electric car and encouraged the smart grid, that they thought we were in the, getting close to having a system where when a windmill goes on at night, it can charge your electric car, and this is all synchronized, which obviously has tremendous savings. But I'm not sure we're that close to that. And I think it's almost a barrier when a utility says, well, we're installing a smart grid, but it doesn't do a lot of things that maybe members of Congress think it would do when they incentivize this. So I'm just wondering, is there terminology we can use, meter reading, load shifting, and then other things to maybe clarify for policymakers what we are and are not accomplishing?
That's very, very good. Smart grid is an overused term because too many things are put under that umbrella. I like to say, let's go down a level and say, what do we really mean by smart grid? And the biggest difference with smart grid than what we've been doing in the past is in the past we've been working with devices and systems, and what smart grid gives us the opportunity to do is integrated solutions. Okay, and by solution we mean it's tailored to meet the business needs of the utility in some way. So we've looked at the strongest business cases of the utility, and they're developing 6 different solutions. Distribution optimization, transmission, asset, demand response, smart metering, and workforce and labor productivity improvement. So I like to drill down and say, what do you mean by smart grid? And then say, what is the integrated solution you're putting together, and what's the value proposition of that? How does that provide value to the utility? MK said that, and this is true, up until now, 60% of the expenditures in smart grid have been for smart meters, which many in the industry think smart grid is smart metering, right? Which is what MK said. Pike Research, Green Tech Media, and some other well-known market research firms in the U.S. have come out and said within the next 3 years, the majority of spending is going to shift to the distribution system, away from smart metering. Has the strongest value proposition that we've talked about. So smart grid is really the reference point for it is floating. What do we mean? To me, it's driven by the value proposition of the customer, and where can the customer make an expenditure and get the biggest bang for the buck? And very shortly, in the next couple of years, we're going to see more focus on distribution.
Yeah, I believe that ultimately economics and value are going to drive what happens with the smart grid. So smart is something we add to a lot of things. I've got smart kids and I've got smart wife and so on. But what we find is that we really need to bring value to the consumers of electricity, and ultimately that will drive what the innovation that is happening. What the government has done and what sort of the people like John are doing is making the playing field easier to get into and making the playing field open, and that's a good thing. And that's really what happened in the telecom area. It happened in the internet area. So we believe that as we bring value and we bring cost savings to our customers, that's going to drive a lot of innovation, not necessarily one standard or the other.
Yeah, I just think actually it's not smart grid is kind of like there's a joke nine blind men looking at an elephant, and every blind person defines it into what he's touching. Somebody touching the trunk says the elephant is like a big tree or something, but it's really the digitization of the grid, and really it's the digital grid. One of the things we're really used to in this country, in the United States when I first came here, is that we're so used to having power whenever we need it. We leave the lights on, we leave the air conditioner on, we leave the TV on, and we never question, where all this is coming from and what are the implications. And so that's one of the things that we need to start thinking about. There's movie I was watching with my daughter, Karate Kid, and over there the Chinese water maintenance man says, your water heater is fine, you just got to turn it on, and then the kid says, well, we don't have a switch in America. And it's like, well, maybe you need one, and that's true. We do need to think of energy that way, is that we use it only when we really need it, and not just have it.
I'm Stefan, student at Georgia Tech. Just one question from your discussion with utilities. Has there been any concern about the infrastructure for getting the data in? Because we've been talking a lot about, we have all this data magically appearing at either the utility or at the companies, but a lot of this infrastructure, it's going to be, from what I've heard from previous talks, has been going through the wireless communications, these cell phone networks. And what if that was to go down, either because so many people are on the phone at the exact same time so they can't use it? Is there like a backup plan for that, or is it just the information is not going to be used, or is that actually a concern of the utilities?
It's a huge concern. It really is. I say, for smart grid to be successful, there's 3 foundational technologies that need to be in place, and this is where we get into infrastructure. In other words, before you layer any smart grid application on top of your system, if that foundation isn't robust, it's not going to support it. Your smart grid's not going to be successful. Two of those, or three of the 3 are the IT infrastructure, right? We talked about that, almost all 3 of us. Be able to manage data in the enterprise and move data from the operational side to the IT side. These 2 groups in the utility typically don't work well with each other at all. Operations has a sense of urgency that if something breaks, there's data that I'm not getting and I got to fix it right away. IT doesn't have that sense of urgency. So these 2 groups typically don't work well with each other. So they're concerned about it, but because of the silos, haven't made the progress. Second is communications infrastructure. Communications enables us to automate. Smart grid is about automation. So if I could have a smart grid application, but it requires response requirements, latency requirements, and bandwidth, if I don't have the technology, and my communications technology support the requirements of my smart grid application, my application won't be successful. So there's legacy communication technologies in place in utilities that won't support new smart grid applications that need to be upgraded. Okay, and then the third is the geographic information system that MK talked about, because that gives us the network model for our distribution management system. It has the longitudinal, latitudinal coordinates of all of our assets in the network model. And we have to make sure that's modeled down far enough in the distribution system to support our distribution management system. There's a lot of concern. Those 3 have to be successful before you think about doing anything with smart grid. But to truly reach the point that utilities need to reach, they're concerned about it, but these different groups all need to work together to be successful, and that's the challenge.
Well, it's a little after 1:30, and it's time. Fortunately, we've got to bring this to a close. But let's please thank our speakers for their great time. And just remember the next program, Wednesday, April 27th, where we'll look at plug-in hybrids in the grid. Thank you.